Assalamualaikum and hello everyone. Welcome back to chapter 5 vectors. Now, we are in the last subtopic 5.4 application of vectors in geometry. In this subtopic, we will learn to find the equation of a straight line, determine the angle between two straight lines, find the equation of a plane, determine the angle between two planes, determine the angle between a line and a plane, and also determine the point of intersection between a line and a plane. So in this video, we will focus on the equation of straight line. Suppose that R is a point which is free to move on a line containing a fixed point A. In another word, R is a random point and A is a fixed point on the line. The line is parallel to direction vector, which denoted as a V. There are three forms of equation of straight line: vector equation, parametric equation, and Cartesian equation. Starting with vector equation, we know that ER is parallel to the V. And then we're going to have ER equal to TV, where T is element of real number. So by resultant vector of ER, we're going to have OR minus OA. So from the origin to coordinate R, we let as a vector R. And then from origin towards coordinate A, we let as a vector A. Substitute these two vectors into the equation. So we're going to have R minus A equal to TV. Then we make it R as a subject. So we're going to have R equal to A plus TV. So for the vector equation, you have to give the final answer in terms of direction component. Next, for parametric equation, we change the vector equation in terms of column matrix form. Then we will separate according to direction component. So we're going to have x equal to A1 plus TV1, y equal to A2 plus TV2, z equal to A3 plus TV3. Then we're going to have Cartesian equation from parametric equation by rearrange the function by let t as a subject. So we're going to have x minus A1 over V1, y minus A2 over V2, and z minus A3 over V3. So we equate all these functions to become one equation and make sure the coefficient for x, y, and z must be equal to 1. So let's try a few examples. Example 11a. Find the vector equation, parametric equation, and Cartesian equation of the line through a coordinate in the direction 4i plus 5j minus 6k. So let's draw a line first. And then we put a point on the line. And we have it the direction of 4i plus 5j minus 6k. So by vector equation, substitute these two vectors. We're going to have r equal to I minus 2j plus 3k plus t times 4i plus 5j minus 6k. So that's our vector equation. So next, we change to be parametric equation. So we're going to have x equal to 1 plus 4t, y equal to negative 2 plus 5t, and then the z will be equal to 3 minus 6t. And then next one, which is Cartesian equation. So we rearrange to make it the t as the subject for x, y, and z. So the final part of Cartesian equation, you have to equate all of them as a 1. So we're going to have x minus 1 over 4, y plus 2 over 5 equal to z minus 3 over negative 6. Okay, so let's move to 11b. Find a vector equation of the line that contains points A and point B. So we have 2 points on the line. So for equation of line, we need a fixed point and direction vector. So to find the direction vector, it's gonna be equal with AB since V is parallel to AB. So by resultant vector, we can have OB minus OA So your direction vector is 3i minus 4j plus 8k. So for the fixed point A, we will choose from first point, which is point A. Then we substitute these two vectors into the vector equation. So we're going to have your R equal with 2i plus 4j minus k plus t 3i minus 4j plus 8k. Easy, right? So we can move to the next example. Example 11c. A line has Cartesian equation. Find a vector equation for a parallel line passing through a point with position vector and find the coordinate of a point on this line where y equal to 0. So basically in this question, we have two lines. One line already have it, the equation, and then another line we have to find the equation of it. So based on the information given, we're going to have position vector. So let's say the line that already have an equation we let as the L1. And then you have to find the L2 now. So put the position vector on the line. So we know that the two lines are parallel to each other. So we're going to have V1 parallel to V2 as well. It means we can have it the V2 equal to V1. So the V1 we will find from the equation of line, which is on the denominator. So we can have 3i plus 4j plus 5k. So next, we just substitute into the vector equation. So we're going to have R equal to 5i minus 2j minus 4k plus 3i plus 4j plus 5k. Then we have to find the coordinate of point on the line where y equal to 0. So we change the vector equation to be parametric equation. So it's going to be x equal to 5 plus 3t, y equal to negative 2 plus 4t, and the z, which is negative 4 plus 5t. So since we have y equal to 0, we can compare with the negative 2 plus 4t. Directly we can have it the value for t, which is equal to half. So for the value for x and z, we have to substitute the value for t into the function. So directly your x and z, we're gonna have coordinate 13/2, 0 and half. Okay, so I think that's it for now. I will see you in the next part. Take care and bye bye.